Wow, UTME is here already with us. Yeah, just in a couple of weeks now. Is it up to a week? Or in a couple of days now, we're going to start UTME 2026 UTME. And that's why it's necessary that you watch this video, because we are already on the final revision classes for 2026 UTME. So I'm going to spend some minutes talking about temperature and its measurement. And we're going to discuss temperature with various questions. I promise you that we are going to cover every aspect of temperature in minutes. Let's begin. Okay, this is still Physics Meal, a part of Mathematics and Science Meal program. And today we want to do the revision for 2026 UTME, and the focus will be on temperature and its measurement. So we have question one. We are not going to solve this question. We are going to first of all dwell on temperature a little, then we can actually solve the question, because the question is actually simple. The temperature of 45 degrees Celsius is the same as what in Fahrenheit. We are not dwelling on that now. So let's begin with temperature first. Let's look at what we mean by temperature and other things that are around temperature. Okay, let's go. Now, what is temperature? We said that temperature is the degree of hotness or coldness of a body. So how hot or how cold a body is, that's what we mean by temperature. We can also say that temperature is the thermodynamic property that shows the direction of heat flow between bodies. So the thermodynamic properties that shows us the direction of what? Heat flow between bodies. So, but generally we define temperature as the degree of coldness or hotness of a body. How cold or how hot a body is the temperature of the body. So alternatively, like I said, we say that temperature is a thermodynamic property that shows us the direction of heat flow, where we heat flow from and where we heat flow to. That can only be shown to us by what? By temperature. If I have these two bodies, body P and body Q, let me use a different shape for Q. This P and Q, and we are asked where is the direction of heat flow between P and Q. We cannot actually state, yes, because we don't know the temperature of P and we don't know the temperature of what? Q. So we cannot say that heat flows from P to Q or heat flows from Q to what? P. But once we indicate their temperatures, we can actually determine the direction of heat flow. Let's say that this is at a temperature of 23 degrees Celsius, and this one is at a temperature of 75 degrees Celsius. Definitely, heat will flow from Q to what? P, because Q is of a higher what? Temperature. So without indicating temperature, we cannot know the direction of heat flow. And that's why we say that temperature is a thermodynamic property that shows us the direction of heat flow between bodies. So once we indicate the temperatures, we can now say that heat flows from Q to P. Why? P has higher what? Temperature. Heat cannot flow from a body of lower temperature to a body of what? Higher temperature. Rather, heat flows from a body of higher temperature to a body of lower temperature. Okay. Now the SI unit of temperature is Kelvin. So Kelvin with the symbol K is the word SI unit of temperature. There are other units of temperature. There are so many other units of temperature. What are other units of temperature? We have the degree Celsius, this degree Celsius, and then we have the degree Fahrenheit. The degree Fahrenheit. So about the SI unit, in physics we deal with SI unit a lot. So the SI unit of temperature is actually what? Is Kelvin. It's Kelvin. Okay. The instrument we use in the measurement of temperature is thermometer. So thermometer is the instrument used in the measurement of what? Of temperature. So the instrument we use in the measurement of temperature is actually what? Is thermometer. That's the instrument we use in the measurement of temperature. Now this thermometer must be calibrated. Yes, we must calibrate it. The thermometer must be calibrated. What do we mean by calibration of a thermometer? You need to mark it. But for you to mark a thermometer or to calibrate a thermometer, which is the instrument we use in the measurement of temperature, we need to know 2 points. There are 2 points that must be ascertained. The 2 reference points that must be ascertained before you can actually calibrate what? A thermometer. And these 2 points are called fixed points. We call them fixed points. We have the lower fixed point and we have the what? The upper fixed point. So the lower fixed point and the upper fixed point are the 2 points that must be fixed before we can do what? Calibrate what? A thermometer. The 2 points that must be fixed before you can calibrate a thermometer are the upper fixed point and the what? Lower fixed point. So we take this down. The fixed point. The fixed point. So the fixed point in thermometer. Fixed points in thermometer. We say there are 2 fixed points in thermometer. 2 fixed points in thermometer. One is the lower fixed point. So what's the lower fixed point? Lower fixed point is the temperature of ice melting at normal what? Atmospheric pressure. So temperature of ice. Lower fixed point is temperature of what? Ice melting at normal atmospheric pressure. Temperature of ice melting at normal atmospheric pressure. That's what we mean by the word, by the lower fixed point. Lower fixed point. Temperature of ice melting at normal atmospheric pressure. Then we have the upper fixed point. Upper fixed point is temperature of water boiling at normal atmospheric pressure. So the temperature of water boiling or temperature of boiling water at normal atmospheric pressure. That's what we mean by the word upper fixed point. Now, we have values for the upper fixed point and the lower fixed point depending on the temperature scales. The 3 common temperature scales that we have are, we have the Celsius or centigrade scale, we have the Fahrenheit scale, and we have the absolute temperature scale. The centigrade scale, the Fahrenheit scale, and the absolute temperature scale. And these 3 temperature scales, they have their own word, lower fixed point. They also have their own word, upper fixed point. So the upper fixed point in word, in centigrade scale, is not the same thing as the upper fixed point. They are not of the same value as that of what? Fahrenheit scale, and you cannot expect them to be of the same value for that of what? Kelvin scale or the absolute temperature scale. So we are going to look at the various fixed point values. That's the values of the lower fixed point for each of the temperature scales that we have mentioned. So we have the centigrade scale, the Fahrenheit scale, and we have the what? The absolute temperature scale. Don't panic. You will succeed in your UTME. I know so many people have shouted just amen now, because that's what students always want to hear. Once you tell a student you are going to succeed in this exam, you shout amen. Even those that are not studying. But for those of you that have really studied, don't panic. The exam is going to be easy. So let's go back to our business. So we're going to look at the fixed points, the values of the fixed points, the lower fixed point, the upper fixed point for centigrade scale, for Fahrenheit scale, and for what? Absolute temperature scale. But before then, the difference or the distance, the difference between the upper fixed point and the lower fixed point is known as what? Is known as fundamental interval. So I can say, note, the difference between the upper fixed point and lower fixed point is known as fundamental interval. Fundamental interval. That's the difference between the upper fixed point and the lower fixed point. So let's look at the upper fixed point and lower fixed point of different temperature scale together with their fundamental interval. I wrote this last, so I'm not going to clear it for now. So let's look at the upper fixed point and lower fixed point. So we look at temperature scale. Let's see, we have temperature scales here. So let's use LFP. And let's write it in full. Okay, LFP. Let me take this as my word. Lower fixed point, short form. Then let me use UFP. Let me call it the word upper fixed point. And let me use FI as fundamental interval. At least we know what they mean. Lower fixed point, upper fixed point, fundamental interval. Remember, the lower fixed point can also be called ice point. The ice point. Another term that can be used to describe the lower fixed point. Lower fixed point. So when we say ice point, this is the lower fixed point. So lower fixed point is ice point. In other words, melting point. Then upper fixed point, we still call it the steam point. So whenever you hear steam point, it's talking about upper fixed point or boiling point. And when you hear ice point, it's talking about what? It's talking about the lower fixed point. Take note of that, because it will be very vital when we start looking at different types of thermometer. Okay? So let's look at this together. So let's talk about the centigrade scale. The lower fixed point of centigrade scale is 0 degrees Celsius. Upper fixed point is 100 degrees Celsius. So the fundamental interval is the difference between the upper fixed point and the lower fixed point. And that's 100 degrees Celsius. Okay? For the Fahrenheit scale, the lower fixed point is 32 degrees Fahrenheit. Upper fixed point is 212 degrees Fahrenheit. And the fundamental interval is this minus this. That will give me 180 degrees Fahrenheit. For the absolute temperature scale, or the Kelvin scale, the lower fixed point is 273 Kelvin, upper fixed point 373 Kelvin. Then the fundamental interval is this minus this, and that will give me 100 Kelvin. 100 Kelvin. Okay? So that's the table showing us the lower fixed point or ice point. Remember, we said that the lower fixed point is the same thing as what? Ice point. And this is the word upper fixed point or what? Or the steam point or boiling point. Then the fundamental interval, which is the difference between the upper fixed point and the lower fixed point. Now, you have to also note this. The instrument we use in determination of upper fixed point, we call it hypsometer or hypsometer, whichever one, but just know the spelling. The hypsometer or hypsometer. The instrument, we use this in the determination of what? Of the upper fixed point of a thermometer. The upper fixed point is determined using the instrument we call the hypsometer. You know, this is a revision class, so every important point we need to pick them one after the other. Okay, so let's move on. So what are the relationship between this temperature scale? We're going to see the relationship between centigrade and the what? And the centigrade and the Fahrenheit. We also see between centigrade scale and the what? Absolute temperature. Because it's revision, we will not be looking at the derivations of these particular expressions. We'll just go straight and look at the relationship. So, relationship between temperature scale. Relationship between temperature scale Kelvin. So first, between centigrade and Fahrenheit. What's the relationship between them? Temperature in Fahrenheit is connected to temperature in Celsius, that's in centigrade. What's the relationship between them? A very simple expression. We're going to see that. F is 1.8 C plus 32, where F is the temperature in what? In Fahrenheit, and C is temperature in what? Temperature in Celsius, right? This temperature in Celsius, this temperature in Fahrenheit. Okay, so we can actually mention where F is temperature in Fahrenheit. You know, in physics it's important we define terms. And temperature in degree Fahrenheit, temperature in degree, temperature in degree Fahrenheit, and C is temperature in degree Celsius. So it means that if I know F, temperature in Fahrenheit, I can just put it here and solve for C. And if I'm giving C to find F, I'll just substitute it here, and then I can get my what? My F. Okay, then the next one is between centigrade and the absolute temperature. Centigrade and absolute temperature. Another simple expression that most of us have used, especially when we are dealing with gas laws. Temperature in Kelvin is 273 plus temperature in degrees Celsius. That's a relationship. Where K is temperature in Kelvin. And we have already said that C, here we have defined C here as temperature in centigrade. Okay, so far so good. So based on that, we have arrived at this point. Before we pick our next question, based on that, since we have arrived here, now let's look at this question together. So solution to this question, a very simple question. They say the temperature 45 degrees Celsius, so this temperature is in Celsius, is the same as dash. So these ones are in Fahrenheit. So this temperature, if we convert it to Fahrenheit, what are we going to have? So how are we going to do that? How we are going to do that is to first of all get what? Get our expression, right? So we're giving temperature in degrees Celsius as well, 45 degrees Celsius. We are looking for its equivalent in what? In Fahrenheit. So what's the relationship between Celsius and Fahrenheit? We said that Fahrenheit is what? 1.8 what? C plus what? 32. So what do? Very simple. F will now become 1.8 times, what is our C? 45, then plus what? 32. Now, if you are finding it difficult to carry out this multiplication, maybe because of the nature of the numbers, you know, I can actually change this. Yes, I can change this to become 18 over 10 times 45 plus 32. Okay? So, if we do that, we're going to say that 5 here is already 2, 5 here is 9, right? And then 2 here is 1, 2 here is 9. 9 times 9 is what? 81. And 81 plus 32 will give me my beautiful F as 113 degrees Fahrenheit. And that's the correct answer. When you add 81 plus 32, you have this 113 degrees Fahrenheit. Wow. So that's part 1 of temperature and its measurements. Yeah, part 1 with question what? 1. Yeah, part 1 with question 1. So we have part 2 with question 2, right? Until we exhaust every aspect of temperature and its measurement. Please don't go too far. This revision is very important as far as you are going to write 2026 UTME. Very, very important. See you in part 2 shortly.